And now we are down to our last topic. My name is Shaina Amparo and I'll be discussing regarding the chemical properties of lipids. For our first experiment, it is called the emulsification of fats and oils. So we'll be needing coconut oil, corn oil, margarine, oleic acid, and detergent or soap.
Hello, so today we're going to do a science experiment to figure out why we use soaps and detergents and how they work. So first, I'm just gonna get a regular old jar and I'm gonna pour some water into it. Let's see, there's just some plain water in there. A little bit more. And next I'm gonna get some vegetable oil and pour that into my jar. I wonder what's gonna happen. Pour it in there. You guys see what happened? Did it mix? No? Oh, that kind of looked like it worked. Let's watch and see. Separate. Oil and water are immiscible. That means they don't mix together, they can't mix together. And notice how the water always goes back to the bottom and the oil always goes back to the top. That's because water has a higher density than the oil. And density is related to its weight. So it's a little bit like water is heavier than oil. So now we're going to test and see what happens whenever we use detergent. So I'm going to do the same thing. Detergent that you would use on your clothes. Let me see if I can give you a good visual here. You guys see what's going on? It is going through the oil and it's kind of getting stuck between the oil and the water. It's pretty cool. So it's going through the oil and attaching to the oil and then taking that oil into the water. Shake it up. All right, now let's observe. Oh, there's those bubbles at the top. So you can see the difference. The one without the detergent is still separated. It has the oil and the water in two layers. This one, there's no separation. They're all together. That's called an emulsion. An emulsion is where you have liquids that have mixed together that were previously immiscible. So these are immiscible. But when we added the detergent, it made an emulsion. They mixed together when they couldn't before.
In this method, the water and oil emulsion is stabilized by adding emulsifying agents. A distinct layer is created by mixing in substances such as bile salts, soap, etc., which reduces the surface tension of the water. Once the liquid has been emulsified by one or more emulsifying agents, it appears as small droplets floating in the solution. It is considered positive or a successful emulsification if there is a permanent or stable emulsion of lipid and water, and it is considered negative if there is an unsuccessful emulsion or if the oil and water will form at the top due to the high surface tension of water. Experiment, we have the unsaturation test. In this experiment, we will be able to determine the presence of unsaturated fatty acids or double bonds in a sample of lipids. So let's get into it.
That we are going to do today is about determining unsaturation in the given oil samples. We are using the oil samples. You can see several oil samples over here, like sunflower oil, olive oil, palm oil, corn oil, and coconut oil. In addition to this, we will be requiring things like test tubes, droppers, etc. For the experiment, we will take around 1 ml of the oil sample. We have chosen olive oil over here. And we have taken around 1 ml of the oil sample. Now we are going to put a few drops of bromine water. We are going to shake and see if the color of bromine water disappears. As you can see, the color of the bromine water has disappeared, and this shows that the oil is
Unsaturated fatty acids have double bonds and become saturated when they absorb bromine or iodine. A higher concentration of unsaturated fatty acids or double bonds means a higher iodine need. So it is considered positive if a pink color disappears and negative if a pink color appears. Last, we have the acroline test. In this experiment, we will be detecting glycerol and fat.
Acroline test. Take a small quantity of desi ghee, vegetable ghee and refined oil in 3 test tubes A, B and C respectively. Using a spatula, add a small quantity of potassium bisulfate crystals into test tubes A, B and C. Now, heat each test tube over the Bunsen burner. When oil or fat is treated strongly in the presence of dehydrating agent like potassium bisulfate, the glycerol portion of the molecule is dehydrated to form an unsaturated aldehyde, acroline, which has a pungent irritating odor.
The test used a dehydration process to extract water molecules from glycerol. The interaction of glycerol with potassium hydrogen sulfate produces acrolein, which has a pungent smell. So it is considered positive, or a glycerol and fat was detected if there is a pungent smell, and negative if there is no pungent smell, which means there is no glycerol and fat detected.